Okay, so we see that poles that are of the same type repel each other and that are different are attracted to each other. And so, like we looked at field lines for electricity, we saw that charges, positive charges, the field lines came out of the positive charges and went into negative charges. And so we had a pattern that looked like this. For a magnet, the diagram looks like this, where you have the field lines coming out of the North Pole and going into the South Pole. And you can see again, like the electric field has the greatest intensity right near any one of the charges. This one has its greatest intensity right by the poles, and then the field is quite a bit weaker over here. As you can see, the lines are further apart. If you bring a compass, which is also a little magnet itself, near the south pole of a magnet, it lines up. But here's the question: if you have a compass and its north pole, how would it point to the North Pole? Because the North Pole is supposed to be repelled by the North Pole. So shouldn't it be turning around? And shouldn't the South Pole be retracted to the North Pole? The South Pole of the magnet of the compass? And so that's a bit of a mystery. What's going on here? It looks like something went upside down. And it turns out that back in the old days, where they used to call this the direction north, they would see that this would point towards it and they would start to call it the North Pole because they didn't realize it says point to the north, so this must be the North Pole. And they didn't really realize how magnetism worked um, in a sense. So, really, when you look at the Earth's North Pole, which is the geographic North Pole, is actually a magnetic South Pole, which is why if you took a bar magnet and if you let it hung it on a string, you'd find that the south pole um, of the thing points towards away, and the north pole points towards what you think is the geographic north, and that is the geographic north. That's what you're looking for. But magnetically, it's the opposite. The Earth's magnetic field is a south magnetic field up on the northern hemisphere, and it's the other way around, which is why a magnet which is got a north pole points towards the north pole, because the north pole is actually a magnetic south pole. Okay, have fun wrapping your heads around that. But now you guys know something, that the geographic north pole of the earth is actually a magnetic south pole. Okay, and then we'll talk a little bit more about how these south poles are created, or I mean, and what is it that really creates a magnet? What's going on there? I know it is a electron that creates a negative field charge, and then a proton that creates a positive. But what's going on here? So we'll look at that in a little more detail. And so it's just showing, if you had some really thin lines, which way the magnetic field lines would point. And here you can kind of sprinkle some iron filings near a magnet, and you'll kind of see they will align themselves along with the field. And you get a feeling for the field lines by placing these iron powder kind of thing around it. So the Earth, how does it produce a magnetic field? Or how does anything produce a magnetic field? And boys and girls, there's only one way that you can create a magnetic field, and that is by a moving charge. So a charge moves, an electric charge, yes, not a magnetic charge, there's no such thing. If a positive charge or a negative charge moves, as it moves, it creates a magnetic field around it. And that's the only way that you can create a magnetic field. And so every magnet, every type of magnetism that you've ever seen is due to some electric charge moving and causing that magnetic field. Now, if you really, we'll pause for a second because the video ends and then I'll continue.